Welcome to Chapter 13, Part 2. In this segment, we're going to be learning how to calculate binomial probabilities using Minitab. And as I told you in the last installment, that you can use what's called a PDF command in Minitab. That gives you the exact value. That gives you the probability at an exact value. Or you could use what's called the CDF command in Minitab, which gives you the cumulative probabilities. We're going to work with binomials using the cumulative distribution function in Minitab. So we'll be doing a value and everything less than it. And we ask that you do your homework, your post-quiz, and your quizzes with this, because this is what you're going to be given on the test also. So you need to know how to work in here. But you've already done something very similar when you worked with the normal distribution. Table A was a CDF. So we'll use the same techniques. The only thing we have to be careful of is that this is a discrete distribution. So there is probability at a particular value. So it's going to be, we have to watch the wording of our question to see whether a particular value is included or not included. Well, here are the commands here's the first command for the PDF. Again, rather that you not use that, because you're not going to be given that on a quiz or a test, but you would just do PDF, semicolon, because you have to let Minitab know what probability density function it's doing, what distribution it's in, rather. And so you'd have to let it know binomial and give the parameters. And remember, the parameter is n, the number of trials, and p, the probability of a success. So the cumulative, when we do the CDF, cumulative binomial probabilities, its Minitab command would look like CDF, semicolon, because again, you have to tell Minitab which distribution you're in. You say binomial and give the parameters n and p. When you do this, the output of the sessions window will be the cumulative distribution function when you do this, when you hit enter. So let's look at this particular problem right here. Example 1. Each offspring hatched from a particular type of reptile has the probability of 0.2 of surviving for at least a week. If 6 offsprings of these reptiles are hatched, find the probability that exactly 2 of the 6 will survive for at least 1 week. Now, label an offspring that survives with S for success and one that dies with F for failure. So the probability of a success, they told us, is 0.2. Therefore, the probability of a failure that an offspring dies is 0.8. So now I have my binomial variables. X is the number of offsprings that survive in a week out of the 6 offspring that were born. And now I can get the CDF command in Minitab to actually get the cumulative distribution function. So let's see how that works. So X is the number of offspring from this particular reptile that survives for at least a week, 1 week, of the 6 offspring that were hatched. So X is binomial, and its parameters are 6 and 0.2. N is 6. The probability of success is 0.2. So in Minitab, I would put in these 2 commands, CDF, semicolon, hit enter. Then the subcommand would automatically pop up. And I'd say binomial and give the parameters N and P. So I put 6 and 0.2, and my subcommand with a period. What will pop out in the sessions window is this right here, the cumulative distribution function for the binomial with n equals 6 and p equals 0.2. And it will give me the x value and then the probability of that value or less occurring. So the probability that 0 offspring or less, which would just be the probability of 0 offspring, is 0.26214. The next one is when you see x equaling 1, that's asking for the probability that x is less than or equal to 1. So that means the probability of having 1 offspring survive plus the probability of 0 offspring surviving is 0.65536. So let's take a look at this closer. Now the numbers that you see here, 0.2621, 0.65536, 0.90112, 0.98304, 0.99840, 0.9994, and 1.0000, those are all what we got from the distribution function, the CDF, that we used in Minitab. Just like we got there. But we're showing how Minitab got it. And it's just as I said, when you see x equals 3, that's just the probability that x is 3 or smaller than 3. So that 0.98304 is the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2 plus the probability that x equals 3. Now we look at all of these, and they're all they all are similar. We're going to use this cumulative distribution function to help us solve problems. So if I wanted to find the probability that x equal 2, the only thing I can use is the probability that x is less than or equal to 2. But that's got too much probability. How much probability too much? What's the probability that x equals 0 plus the probability that x equals 1? But we've got a way to subtract that off, right? Because look at x equaling 1. That's just the probability that x equals 0 plus the probability that x equals 1. So if I take the probability that x is less than or equal to 2 and subtract the probability that x is less than or equal to 1, I'm going to get the probability of exactly x equaling 2. So written down, this is what it looks like. So what is the probability that x is less than or equal to 2? That's probability x equal 2 plus the probability x equal 1 plus the probability of x equaling 0. Subtract off of that x equaling 1 and x equaling 0. We'll be left with x equal 2. So putting those numbers in, this is the answer that we would get. So let's look at this example of inspecting switches. The number of bad switches has approximately a binomial distribution with n equal 5 and p equal 0.1. So we're given the parameters and that x is binomial. They want us to find the probability of getting 1 or 2 bad switches in a sample of 10. What they want is the probability that x equals 1 plus the probability that x equals 2. How do we find that? Well, we're going to see that we've got the probability that x is less than or equal to 2 minus the probability that x is less than or equal to 0. But let's pull that out to see exactly what's happening. So let's take a look. We add up a little more here that if we want the probability of getting 1 or 2 switches, that's just the probability that x equals 1 plus the probability that x equals 2. But using the CDF, we have to say the probability that x is less than or equal to 2 minus the probability that x is less than or equal to 0. Why does this work? Well, let's look what the probability that x is less than or equal to 2 equals. It's the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2. I'm going to subtract from that the probability that x is less than or equal to 0, which is just the probability that x equals 0. And you can see if we cancel those out, what's left over? The probability that x equals 1 plus the probability that x equals 2. That's exactly what we were looking for. So let's make the CDF in Minitab. So we'd say CDF binomial 5 0.1, and we get this. So to find that probability that x equals 1 or 2 switches, that there's 1 or 2 bad switches, I would just take, when x equals 2, the probability that x is less than or equal to 2, 0.99144, and subtract from that the probability that x is less than or equal to 0, 0.59049. So I'd get my probability to be 0.40095. Now in your Minitab examples on Blackboard, I have 2 more examples for you to look at. Looking at the cumulative distribution function and how you would solve these problems. So it looks like this. It's for your example, it's example 9. It might be a letter now in yours, but it's the one that has binomial distribution. And what you're going to find on there is that on our binomial distribution, you'll see a column that I did for PDF and CDF and how the CDF is generated, and you can literally add the numbers together to see how it works yourself. And then please go through these problems to see that you can get the same answers that I do. In our next installment, we'll do a couple more examples and talk about the mean and standard deviation of a binomial distribution.